You're in Precalculus lesson 1-10, polar and rectangular form of complex numbers. Today's date is Friday, September 18th, 2020. Our objective today is to do what, Emily?
Convert back and forth between polar and rectangular form.
Yep, and you've kind of been doing that. I haven't been calling it polar form. I know I kind of like added it after the fact in our notes from 1-9, which didn't we learn 1-9 all the way back on Monday? Anyway, we are going to be officially defining polar form, which is a really long and tedious form, but it's really, really nice too. It's the only way that we have to represent it. All right, so before I jump too fast, let's go ahead and remind ourselves, if I'm talking about the modulus, again, the modulus is synonymous with our length or our absolute value, all of these terms. This modulus here, what is the formula for the modulus? And if you don't remember, this is pulled directly from 1-9, and I think that's pulled from 1-8 also. You've seen this multiple times. Yeah, Beverly?
The square root of a squared plus b squared.
A squared plus b squared, that is, and square rooted, thank you. It's just another formula that you have to have in your back pocket. I'll go ahead and write the word modulus on here too. Modulus, a word that you have to have down in the future. What about theta? Find theta. And I know there's a bunch of steps, but generally there's just a formula that you need to know. Ellery?
You take the arctan of b divided by a.
There is arctan of b divided by a. And we'll put a note on here. So we'll put like a little asterisk, which is make sure, we'll say correct instead of right, because that might confuse people. Right, left, make sure correct quadrant. And for our domain, we don't care about the domain anymore. Those problems were extra hard because you said, I want a domain between negative 180 and 180 degrees. We don't care anymore. That was just for like the harder practice. So we only need to make sure that we're in the correct quadrant. And again, the only thing that we have to check is if we want to be in quadrant 2 or 3 in the left quadrants, we need to add 180 degrees or add pi radians, either one of those two on the left-hand side. And that's just a reminder from 1-9. And you can always add 360 as many times as you want, which will start affecting our answers, not in this lesson, but in a future lesson. All right, so rectangular form. You've seen him, her, it before since 1-2. Rectangular form is what? These two things added together. Do you remember that form? I'm just going to start cold calling to get everyone in here, and then I can call on people multiple times. Caroline, what's rectangular form? Something plus something. I'll give you a hint. The first letter is A.
Is it a squared plus b squared equals c squared?
Ooh, so close. It's not. There's no squares. There's some I in it too, some imaginary part. And there's these two things being added together. It's A plus
B,
and you're missing one extra part to make it imaginary.
I.
Yeah, there it is. That's rectangular form. A plus BI, and that's our general form. I know I hate putting students on the spot like that, but I just need to make sure that we all have a voice. So let me just do a few examples down here in a different color. So I'll say, this is my example. My example would be, I don't know, you guys don't copy my example. Make your own example. Get your own. Mine's going to be 2 plus 3i. You could do -3 minus 7i or pi plus ei. You can do a bunch of fun things, okay? Polar form. This you haven't seen before, although you're used to finding the parts to it. Generally speaking, by the way, I forgot to say explicitly, but I'm calling R the modulus because down here, I don't want to write out modulus or absolute value. I just want to use a simple variable. So polar form looks like this. It's the modulus, R, again, that length number, times this giant set of brackets. And it's going to end like over here. So make sure you give yourself plenty of room. It's R times cosine of your argument, theta. So cosine of theta plus I times sine of your same argument, also known as theta. And then I'm going to end my square brackets. And this is the point where you say, what? Oh my God, look at those two. There's two forms. One of them's a plus bi. The other one's r plus times cosine of theta plus I sine of theta. Yeah, it's a kind of a monster, right? But they're the same thing. They're representing a point that is a complex number. Or they're just representing a complex number, and that can be graphed. This polar form is really, really good for doing rotations. So you can do a little rotation mark. Rectangular, and they're really, really bad at going up, down, left, and right. So I'll do up, down, left, and right, maybe cross that one off. But for rectangular form, they're really, really bad at doing rotations, but they're really, really good at going up, down, left, and right. So depending on what we want to do, you might need one form or the other. And the whole point is I've been teaching now how to get in between these things. And this lesson is dedicated to make sure you know how to get between rectangular and polar form, because in the future, they're going to give you a problem that's in rectangular form. They're saying, hey, rotate this. You're like, okay, dang it, turn it to polar form. And there's a answer it in rectangular form. So you go turn it into polar form, rotate it, and then turn it back into rectangular form. You're going to go bouncing back and forth between these forms. You need to be masters at converting them between rectangular and polar form. So, and as an example of what you might see for polar form, this is still my example column, you might see something like 7. And by the way, modulus is always positive. You'll never have like a negative 7 here. 7 times cosine of 30 degrees plus I sine of 30 degrees. By the way, this argument is just repeated. It's copy pasted. So it's a little bit inefficient in terms of writing it, but that is how you write out polar form. You'll never have two different arguments, two different thetas here. They'll be the same theta. And it's always I sine, it's never I cosine. Cosine is your real axis, right? Cosine gives you real, and then sine gives you imaginary. So that's why we have the imaginary I multiplied by that sine. Okay. Then you need to be able to go backwards also. And I gave you guys the formula. You always have to, maybe I should do step 1 up here. A hidden step 1, check for special right triangles. That should be your first step. Like if they gave you an angle or an argument that's 60 degrees, you should be going ding dong, oh yeah, 60 degrees, that's a 30, 60, 90. Or maybe they gave you something like a cosine of 125 degrees. 125 degrees is a form of a 45, 45, 90 triangle. You need to always be on the lookout for these special right triangles. That should always be your first step. But on the off chance that they said, find cosine of 13. Yeah, 13 is not a special right triangle, and you'll use these formulas, which I've given those in lesson like 1-8, I think. And they are, what? Do you remember? It's going to use some trig, if you remember. And no one is looking like they know. Go back to your notes. You should have the notes right there, right? 1-8. I think I did in 1-8. Maybe 1-. Oh, it was 1-9 actually. Sorry. 1-9. It's definitely in our notes. There's some cosine and sine and stuff to find A and B. There's a shortcut that says, hey, this will always work. It won't get your number exactly. You'll have to round it. But A and B can always be found with a bit of trigonometry. No? I might be mistaken in how to do this then. Ellery, do you see it?
Yeah, maybe. So you take the absolute value of z times the cosine of theta plus the absolute value of z times sine of theta I.
Yep, that's it. And then I'm calling that absolute value r in this case instead of absolute value of z. So I'm going to just say r in the place of absolute value of z. So I'm going to say r times, oh, what just happened there? R times cosine of our argument theta. And b is going to be r times sine of that same argument theta. Welcome, Aurelio. If you don't mind turning on your video, I'd appreciate it. Okay, and let's try an example. So I have a polar form complex number. A complex number in polar form is the correct way of saying that. And I'm calling this thing Z1, not Z2, not Z3, Z1, Z sub 1. And it's 3, the modulus is 3, so maybe you want to put an R up above that. Its argument, angle here, is 30 degrees. And just from that, you don't really need the rest of this stuff. You don't need the cosine, you don't need plus I sine, you don't even need the second 30 degrees. Basically, the only information you're taking is R is 3, theta is 30. From there, you should be able to express your answer in rectangular form. And notice here, I didn't say round, I said exact. And remember, the word exact means it's a special right triangle. You need a square root probably. in your numbers. Some of them might not have a square root, but you should be expecting maybe some of these to have a square root. So my first step that I'm going to be doing for this problem is draw it out. Where does this thing live? You can just see right here, oh, it's at 30 degrees. So if I come over here on the left, I have some room to draw 30 degrees. Again, here's 0 degrees. Maybe I should use a different color here. Let's use green. 0 degrees comes out straight to the right. That means I haven't moved. So 30 degrees is a little bit up. There's 30 degrees. And how far did I move? I moved a total distance, a modulus of 3. So this length here is 3. And that's where that point lives. So hopefully we'll get in the habit of, okay, every single time I see either a polar form or a rectangular form, I should be able to tell roughly in which, definitely what quadrant it is in, and then where within that quadrant it is. So I'll go ahead and mark our diagram. This is a 30-degree angle and has a modulus of 3. Okay, so what I'm going to do now is I'm going to draw out my 30, 60, 90 triangle. So here it goes. And of course, my computer wants to lag every single time I try to do any drawing, which is annoying. I need a more powerful computer here. So there's my 30, 60, 90 triangle. It's better than I've done in the past. I'm going to go ahead and label this thing. It's 30 degrees in the bottom left, 60 degrees in the top right. And I know that the modulus here is 3. The length of the hypotenuse of this 30, 60, 90 triangle is 3. Okay, and then we get a bit of review in here. I'm going to need some more volunteers here shortly. I'm going to be calling on people I haven't called on before. How do I get from the hypotenuse, which is 3, what operation do I do in order to get to the short leg? This is definitely one of those things that it is useful for this class, especially, but you're going to see this on the SAT too, if you're planning on taking the SAT. So I see a few raised hands, but I've called on you before, Beverly. I'm sorry, I called on you before, Ellery. Let's call someone new. Leo, help me out. How do I get from the hypotenuse to the short leg, Leo? What operation do I do?
Don't you divide?
You do. You divide by what? Sorry, say it one more time. You cut out.
What happened?
Divide by what?
By 2.
Yep, exactly. Thank you, Leo. Yeah, divide by 2. Everyone write it down. We now get 1.5. All right, another volunteer. What operation do I do to get from the short leg to the long leg? Who hasn't participated yet? I don't think I've heard from Oscar. I know Carolina was raising her hand. I don't know if I ever called on her though. And Aurelio is new, and he should know how to do this now. And I think, is that Emily's forehead? I can't tell. I think that's Emily's forehead. Her eyebrows went up. I think that's her. Yeah, one of you 4. Emily, Caroline, Oscar. Yeah, Oscar, I think your hand was up, right? Yeah,
You already
Oscar, go for
called on me before.
it. Okay.
What?
So it's between Oscar, Emily, and Aurelio. And Oscar, yeah, go for it.
I'll go. Isn't it? You multiply by the square root of 2?
Ooh, not square root of 2. It's the square root of.
I don't know. Square root
If it's not square root of 2, it's the next number up, right?
3.
Yeah, multiply by square root of 3. Did I mishear you, Caroline? Did you say you have or have not?
You have.
Okay.
Okay.
Sure. Yep, so multiply by square root of 3, and now we have down here 1.5 square root of 3. Okay, we have all of the parts of our triangle now. Remember that imaginary goes up and down, real runs left or right, and we have to be careful. Are we going down? That would mean we're doing a negative I. Are we going left? That means we're going a negative real amount. Luckily, this is a nice and easy problem. I'm going right, I'm going up. These are both positive, but you need to check. Are these negative or positive amounts? Am I moving up, down, left, or right? So who can give me my final answer? I mean, we have our numbers. You just need to put it in the right answer, right form. Emily, you want to do this for us?
I don't know.
I'll help you out. So the real goes left and right. So which one of these is the real?
Real would be 1.5.
1.5. square root of 3, actually. So the real is this one right here. Okay, and then we add the imaginary, but we need to multiply the this component by some imaginary unit. So tell me what to write down now. Do I do plus or minus?
Plus
Plus, yeah, keep going.
1.5.
1.5, and to tell me that it's imaginary, what do we also have to have with the 1.5?
I.
Exactly, yeah, you got it, thank you. Everyone make sure that you have their final answer written down. Go ahead and box it. All right. I'm just curious too, give me a fist of 5 on how well you can do a problem like number 1 if I just change the numbers around a little bit. 4.5 from Leo, 5 from Beverly, 5 from Ellery, 2 from Caroline, 3 from Emily, 3 from Oscar, and 3 from Aurelia. Okay, cool. That's good. We're going to get better and better the more that we try these. Okay, so I should have done this review before since we were dealing with radians, but let's definitely review it now, our radians. So I have 5 pi over 6. How do I convert that to degrees? Do you guys remember there's a certain fraction that I can multiply 5 pi over 6 by in order to multiply that or convert it into degrees? And I don't have enough time to give the proper amount of wait time, so I apologize. But I need to multiply by something with pi in the denominator, because if I get rid of pi, it is not in radians anymore, and it's in some other unit. So my unit is going to be degrees. I'll put the little circle that indicates I'm in degrees. And I can't just multiply by 2 or 5 or some random number right here. I have to multiply by 1. So I have to have something that is equivalent to pi radians. So pi radians is that amount. How many degrees is pi radians?
180.
It is 180, but next time if you could raise your hand, Emily, I'd appreciate it. It is 180 degrees, perfect. So 180 degrees over pi radians is the same thing as multiplying by 1, and look at what we've done. Pi and pi cancel out, and I'm left with 5 times 180 degrees over 6, and our units are now degrees. Of course, there's a bit of cross simplification that we can do. I think that's what we call it, right? Where I can say, oh, 18 and 6. 6 goes into 18 3 times. So 6 goes into 180 30 times. I can cross this off and say that's 1 now. Cross this off and say that's 30 now. And now I have the problem 5 times 30 degrees. And that's a little bit more straightforward. 5 times 3 is 15. So 5 times 30 is 150. And vice versa, if you ever need to multiply and convert 2 radians, you'll just take the reciprocal of this fraction. You want radians, so you want pi in the numerator. So just be aware you can convert 2 radians to if you need to. All right, we're on the second side. Example number 2. We have this thing. I should have scrolled down so you guys can copy it down. I'm sorry. I was not thinking on my part. But maybe some of you already have it copied down. I have, again, a polar number, polar form, and down here I have a rectangular form where I need to convert to polar. So I want to first start by trying to draw this. And it's really hard to draw because I don't know where 5 pi over 6 is off the top of my head, unless I'm really, really good with my radians already from last year. Where is 5 pi over 6? So the first thing that I want to do is I want to convert 5 pi over 6. So I'll do that off over here, I think it's fine. So 5 pi over 6. I want to get rid of radians. So just as review what we just did. Aurelio, are you there? Can you help us? What do we multiply by?
Yeah, I'm here. All right, what's the question?
How do I convert this 5 pi over 6, which is in radians, into degrees? I multiply by a certain fraction that I just showed up above, and I can maybe show up above so you can see what fraction do I multiply by.
Hold on, give me a second. The dog's going wild. All right, ask the question one more time.
Okay, I have 5 pi over 6 radians.
Okay.
Just like I have right here, 5 pi over 6 radians. What do I multiply by in order to get to degrees?
I'm not sure.
So I literally have the same problem. You can just tell me what to copy down. What's the next fraction after 5 over 6 here?
180 over pi.
There it is, yeah. 180 degrees over
That's
pi.
it?
Thank you.
Oh,
That's it, yeah. So multiply by 150, what was I saying? 180 degrees over pi, and blah, blah, blah. We've done this before. We know how to convert this. Yes, it is going to be 150 degrees yet again. 150 degrees. Okay, so now we can sketch this thing out. Where is 150 degrees? Well, it's not 180 degrees. Again, if I had 180 degrees, that would be all the way over here to the negative reals. It's a little bit less than that. So it's going to come up here and then back a little bit, back 30 degrees. And that's an important distinction to make. Back 30 degrees. Oh, 30. You should be thinking 30, 30, 60, 90. That's right. So it's going to come out here at 30 degrees. And the length of this line is 8 because it tells us in our polar form the modulus is 8. This is our r, this is our theta. Okay, so we need to draw out our 30, 60, 90. I think I have enough room to do it up here. We know that the hypotenuse is 8. We know it's a right triangle. I need to move around this triangle. I don't even want to tell you which direction to go because hopefully you guys have figured that out by now. And I've called on everyone, so I can call multiple people now. Okay, what should I do? How do I get from 8 to some other part of this triangle? Beverly.
Divided by 2 to go to the
Okay.
left.
Oh, to the left, yep, that short leg. Say divide by 2, and that's 4. I can do the math for you. You're welcome. Thank you, Beverly. How about this long leg? What do I do? Ellery. Uh-oh, technical difficulties.
Wait, can you hear me?
Yes, now again.
Okay, yeah, multiply by the square root of 3.
There it is, yep. Multiply by the square root of 3, and we get 4 root 3. And one final volunteer, what is my answer? Oh, you have to be careful about negatives too for your final answer. So don't just write 4 plus 4 square root of 3, or 4 square root of 3 plus 4i. That is not the correct answer. Be careful of your negatives. What's our final answer? I guess I'll just flip-flop between Ellery and Beverly. Yeah, Beverly.
4 times the square root of 3 minus 4i.
Like that? Yep. I'm making the face because it's not quite
Yeah, I know.
right.
I don't know.
You're really close. I'll write those numbers. 4 square root of 3 is the real part number, and then 4 is the imaginary part number, but you have to figure out if it's a plus there, a minus there, a minus there, a plus there. Again, think of our original graph. Do we move left or right?
Wait, would it be minus 4 to the square root of 3 plus 4i?
It is indeed, yeah, because we move
Okay.
left and then up.
Okay.
Perfect. All right. And our final example 3, we have 2 minutes and, oh, we don't. We have 4 examples here. Yeah, we're going to try to do example 3 in the 2.5 minutes that we have left. And then example 4 is going to be part of your additional homework tonight, in addition to the content assignment. If you need to see how to do example 4, I will have this video finished online if you need to see it. Unfortunately, I don't have enough time to let you try this too much on your own. I'm going to go ahead and work through this with you. 3 minus 3i, again, I always want to draw a picture. 3 minus 3i, I go right 3, down 3. So 3 minus 3i lives right there. 3 minus 3i. Notice that it kind of makes this 45-degree angle if you have drawn this correctly. A 45-degree angle with our real axis. So let me go ahead and drop a line to the real axis. And I can label this triangle. This triangle looks like this. It's at 45, 45, 90. And I know I went right 3, so this top length is 3, and I went down 3, so I can say minus 3 if you want, but it doesn't really matter. You can say, I guess we'll leave it minus 3. It's a 45, 45, 90 triangle, which means I can move from either leg, it doesn't matter which leg, so I'm just going to randomly choose this top leg down here to the hypotenuse, and I'm going to multiply by the square root of 2 to get 3 square root of 2. We now have the modulus. Again, you have to have 2 components. You have to have the angle, the argument, and the length, the modulus. We've figured out one of them. One of them is 3 square root of 2. So I can start filling in my polar form, right? My polar form is modulus, which is, I'll say R is equal to 3 square root of 2. So my polar form will look like 3 square root of 2, then brackets, watch, it's telling me I have 55 seconds. 3 square root of 2 times cosine of our argument, I'm going to leave that blank for now, plus I sine of our argument. We just need to figure out what our argument is, and we're done. Okay, so how do we figure out the argument? And again, if you aren't sure, just go ahead and use your arctangent function. So you can say our theta is equal to arctangent of, it's going to be negative 3 over 3. And this needs to be in radians. So when we go to our calculator, let me share my screen. Oh, come on, 10 seconds left. Once 11:40 rolls around, you guys can get out of here. You don't have to say. Oh God, it's going to take a sweet time to load. There you go. So I'll say, come on now, arc tangent of negative 3 over 3 is negative 45 degrees. You probably could have figured that out. Back here and say that this is negative 45 degrees, which in radians, if I click that radians button, please let me switch back. In radians, it is this, which you can't use, unfortunately. So we have to convert this to radians. I'm almost done, I promise. So times pi over 180 degrees. So I can say, now what is 45 times pi over 180 degrees? No, I did that wrong. 180 divided by pi, right? No, it is pi over 180. And notice that it's the exact same answer. So we verified it works. Yes, get rid of the pi. Make it a 1. It's 0.25. So it's 0.25 pi. Come back here and say 0.25 pi or pi over 4. And that is our argument here and here. I'll be uploading a video on how to do example 4 if you want to look for that on the website. So homework, finish example 4 and summary, and do the homework on Khan Academy. And for example 4, we need to get this rectangular form into polar form, just like example number 3. So the first thing that I want to do is draw this out. And it's even harder to draw it out now because we have a square root. Like, which one is bigger? Negative 5 square root of 2 or 5 square root of 6? And you should hopefully see, yeah, square root of 6 is bigger than square root of 2. So it goes more in the I direction, more up than it goes left because it's negative, right? So more up than left means I'm going more up than left up here. It's not 45 degrees, it's a little bit more than that. It comes up in this direction. And I have a general picture. I guess I can drop a line to the real axis and go ahead and redraw that triangle out here. So our triangle should look like this, and I'm gonna have to use a bit of the summary space to get my answer down. So what do I know? I know that I went left 5 square root of 2. So this is gonna be 5 square root of 2. I went up 5 square root of 6, 5 square root of 6. And I need to figure out what my angle is. I need to figure out that argument. I need to figure out the modulus, this length here. So which one do I want to do first? I typically find the modulus first. Again, I just square both of these and add them together. So I have 5 square root of 6 quantity squared plus 5 square root of 2 quantity squared, and I'm going to square root that entire quantity. Okay, so how do I do this? You should be able to do this by hand, but you do have a calculator if you need to. This is going to be 25 because I square 5. I square the square root of 6, and that's just turns it into a normal 6 instead of square root of 6. Plus, and then this is going to be again 25 times 2. This is all being square rooted still. So this is still R. The next line down, I guess I can do it in blue. R is equal to 25 times 6, and 25 times 2 is the same thing as 25 times 8. It's that reverse distributive property. But if you want to multiply this out, I guess we can say that this is 150 plus 50, still being square rooted, of course, and therefore R is equal to the square root of 200. And I know that you want to turn this into 10 square root of 2, which is fine. You can do that. You don't have to, though. Why is it 10 square root of 2? Because it's square root of 100 times square root of 2. So this is equal to 10 square root of 2. So you should know how to simplify radicals in this class, but it's not necessary. Khan Academy will still consider this correct, I believe. Okay, that is how do you find the modulus. How do you find the argument, the theta up here? So start in blue now. So theta, again, I'm just going to use arctangent, so tangent to -1 of our imaginary, this 5 square root of 6. 5 square root of 6 divided by our real, this -5 square root of 2. Again, negatives are important. And then this is where I'm going to come over to my calculator. I need to share my entire desktop. So I can just Alt-Tab really quickly between them. And let's go to calculator, close it since I last did this class. And of course it's loading again. I'm gonna do, which one was on top? It was 5 square root of 6 on top. Okay, so 5, come on now. So arctangent of 5 square root of 6, and that's all going to be divided by 5 square root of 2. Oh man, I'm blanking. Okay, and then it was a negative on the bottom. And I get -60. That's in degrees. Did it say degrees or radians? It says degrees, so we don't have to convert this to radians. And yeah, I just say, yeah, -60 degrees. This is -60 degrees. And I write my final answer. Again, our form looks like this. It's going to be the square root of 200, and then square brackets is going to be cosine of that 60 degrees plus I sine of 60 degrees. And then end the brackets over here. And we have our final answer, box it. And that concludes Precalculus Notes 1-10.